Hello, today is like introduction to the resolving forces. We're not gonna have any exactly questions about where. Basically, it's basically like a brief what it is. So, what I mean by resolving forces is basically you have to understand that. Okay, basically, resolving a force is about replacing it with two forces or factors at a right angle to another one another that would have the same effect. So like two forces would have the same effect as the single force. The forces that are being no, the forces that that are replacing the single force, like can be called components of that force. So to visualize that, so let's say we have like a ball, right, and there's a force applied to it, right, and this force makes it go like somewhere over there, right? Like the direction where the force is. We can like kind of not factor but like split that force into two. So basically make it one force up, one left. And you might think, okay, well, how does that work? Well, look, basically, these two are these two kind of pictures, I guess, or examples are equal. Like, let's say, this ball's going this way, and if we could have calculated all the stuff and we like write everything right, the force like it will go the same way, even though they're two. But it works because like one pulls it up, one pulls it this way, and so like it goes kind of in the middle. So I guess they're like equal. However, if this one was more powerful than this one, it would go more to kind of this way. However, if this one was more powerful, it would go like something like this. So it's all about like how strong the force is, blah blah blah. However, an important thing to know is that in questions, most of the time, you will get with the like force a degree, and from that degree we're gonna be able to like calculate it. You might think, well, how are we supposed to why does it matter? Because look, so we have the red one. Oh, we have the red force, we have the blue force, and we have the green force. Yes, I made it bigger, blah blah blah, but that's how it kind of adds up. And over here, there's then a degree, and after that, we're able to find do all the stuff through like cosine Sogator basically. Um, so from that we can know what the components are equal to. So we know that basically this is the hypotenuse, this is the opposite, and this is the adjacent. For the adjacent, we're gonna be using cosine, right? And then we're gonna use this number. So basically we know that cos theta equals adjacent over hypotenuse. Let's call them not that for now. Let's call this A, B, C. So we know that A over C is equal to the theta. So we have to get rid of C on this side to make it A on its own, and we just put this equals to A. So this is what's going to be to find A, and for B is going to be like basically the same thing. So C but sine theta equals B, because like theta sine equals B over C, so put C here, blah blah blah. So that's how it works. And then notice how, where was the example? I didn't have the example. Okay, I'll do the example right here. Oh no. Why did I add them? So, and it's 20 newtons. So we have a force, it's 20 newtons from a 60-degree angle. So let's just write the other two components. We can write them like this. Kind of like, what I would do is that I would just write it like this. Oh. This is how I would do it. And from that, we know that, like, from last time, look, okay, so, the C is 20, like, the hypotenuse is 20 over, like, A, adjacent, and let's just put, yep, so, so 20 cos 60 equals A. Then, I mean, I don't want to check on a calculator, there's no point, because, yeah, this is the right way, and then this one's going to be exactly the same, but sine 60. And important to know that most of the time, wherever you see the degree, that's going to be, like, the adjacent. So let's say, in the exam, we are given two lines, right, already, and we're given this, and we're given this thing, right? You might think that, oh, well, like, if you flip it once, this is going to be like the adjacent, right? Like, it matches the discrete, like, all that type of stuff, blah, blah, blah. However, no, because, like, how can I explain to you? Well, look, first of all, you might think, oh, you do this, like, 90 minus 60, oh, 65. 65 equals 25, so it's 25. No, because let's say in exam, it's much more easier. Like, let's say you wasn't given theta, yeah? You don't have theta. You can't write minus, like, 90 minus theta. Like, just use the actual number that you already have, unless it's telling you that that's not the actual number. And also, if we move it here, we're gonna make a right, like, triangle. Like, if we move this one there, and see, the adjacent is right here. And same with this, you can move it here, and the adjacent is going to be this one that we moved. Yeah. Yeah. So that's kind of the logic.